Okay, so today we're gonna find the formula for what cubes of binomials are. So that's these two cubes that we're cubing binomials, and then we're gonna find the formulas for the difference of two cubes and then the sum of two cubes. So let's first find the formula for the sum of the binomial and then you're cubing it. So if we plug in a value for a and we want to find the cube, we can rewrite this as x plus 1 times x plus 1 squared. And we know what x plus 1 squared is. It's just a perfect square. And we went over this in our last video. But this would evaluate to x squared plus 2x plus 1. And then to evaluate this, you would first multiply x by this entire polynomial. And then you would multiply 1 by this entire polynomial. So let's first do x times that entire polynomial. So x times x squared plus 2x plus 1, and then 1 times that entire polynomial. Okay, so if we distribute the x here, we would get x times x squared, which is x cubed, then x times 2x, which is 2x squared, and then x times 1, which is x. And then 1 times all of this remains to be the same, so multiplying by 1 doesn't do anything. So we could just rewrite the polynomial. Okay, and then now if we add our like terms, so there's nothing to add the x cubed with, so that's gone. And then we have a 2x squared, and then another plus x squared, so 2x squared plus 1x squared is 3x squared. And then we have to add our x and our 2x, so 1x plus 2x is 3x, and then we have 1. Okay, so this is what you get for cubing a binomial, and the formula for cubing a binomial is x cubed plus 3ax squared plus 3a squared x plus a cubed. Okay, so let's see if this actually held true in the product we just solved for. So we have x cubed, and we can see that we have the x cubed, and then we had 3ax squared. For us, was 1, and our x was also x, so 3ax squared. Here, do we have 3ax squared? We have 3 times a is 1, and x squared. So yeah, that's what we got. And then let's see the third term. So 3a squared x. So that means we would have 3 times a, which is 1. So 3 times 1 squared times x, and that's what we got here, which is 3x. And then our last term is a cubed. And we also got a cubed here because of the 1. And here we had a is 1, and then it was 1 cubed. So yeah, that's what we got. So yeah, this is the formula for the cubes of binomials, or also called perfect cubes. And the conjugate of the same formula, which is over here, the conjugate meaning that the operation in the middle is just different. So the conjugate of that formula is x cubed minus 3ax squared plus 3a squared x minus a cubed. So these two formulas make up our perfect cube formulas. And now let's move on to our difference and sum of cubes. Okay, let's form these two equations. So I'll just give you what the formula is first, and then we can plug in some values and see how it evaluates. So for the difference of two cubes, which is this formula over here, it's x minus a times x squared plus ax plus a squared. And for the sum of two cubes, it's x plus a times x squared minus ax plus a squared. Okay. So now that we have these two formulas, let's try to plug in some values and see how they evaluate too. So let's first do the difference of two cubes. Let's say we have to evaluate x minus 1 and then times x squared plus x plus 1. Okay, so that means first we have to multiply x by this entire polynomial, and then we have to multiply minus 1 times this entire polynomial. Okay, so that means this should be equal to x times x squared plus x plus 1, and then minus 1 times x squared plus x plus 1. Okay, and distributing the x between these three terms, we get x times x squared, so which is x cubed, x times x, which is x squared, and then x times 1, which is positive x. And then here, multiplying the minus 1 times these three terms, we have minus 1 times x squared, which is minus x squared, minus 1 or negative 1 times x, which is negative x, and negative 1 times 1, which is negative 1. Okay, and now let's just add our like terms. So x cubed, we only have one x cubed, so that remains as is. And we have x squared minus x squared, so that cancels out to 0. So 1 minus 1 is 0. We have 1x, and then we have minus 1x, or negative x. So 1 minus 1 is 0. And then we have a minus 1. So this means that the product of this equals x cubed minus 1. And we can write that as x cubed minus 1 cubed, which we can see matched our difference of two cubes formula. So that shows that the difference of the two cubes is equal to this formula. And now let's finally do the sum of two cubes using the same method. Okay. So let's say we have to multiply, this time we have to multiply x plus 2 and x squared minus 2x plus 4, which matches this side of the formula. So we can probably tell that it should equal that, but let's just multiply and double check. So we have to multiply the x by this entire polynomial, and then we have to multiply the 2 times this entire polynomial. So x times the entire polynomial plus 2 times that entire polynomial. Okay, so first let's distribute the x. So x times each term, so x times x squared, which is x cubed, x times minus 2x, which is minus 2x squared, and then x times 4, which is plus 4x. Now let's distribute the 2 between these three terms. 2 times x squared, which is positive 2x squared. 2 times minus 2x, which is minus 4x. And then 2 times 4, which is positive 8. Okay. Okay, now let's add our like terms. So we only have one x cubed. And then we have a minus 2x squared and a plus 2x squared, which leaves us with 0x squared since they cancel out. And then we have a positive 4x and a negative 4x. Those two cancel out. So we have so we have 0x. And then we have plus 8. And then we can see that this is x cubed plus 8, which we can rewrite to x cubed plus 2 cubed. Or, I don't need the parentheses there. 2 cubed. Okay. So, as we can see, it converged into that formula. So yeah, that's a basic introduction to the cubes of binomials and also the difference and sum of two cubes. So thank you for watching.